Class, welcome to our notes today where we're going to be talking about the volume of cylinders and cones. You'll notice in the picture here that I have described a right cylinder and an oblique cylinder. And the reason I wanted to show both is so that everybody could remember that we don't always have cylinders that are standing perfectly straight up and down. So for example, this first one is a right cylinder, and if it is standing straight up and down, then the height is automatically perpendicular to the base. However, some cylinders could be oblique, meaning that the cylinder is kind of slanted sideways. If that happens, just look very carefully for the height. The height still has to be perpendicular to the base. In that case, that height may be shown outside of the cylinder at times. Now, what do we know about volume again? If you remember volume of prisms from one of our earlier lessons, if we needed to find the volume of a prism, let's say it was a square prism where the top and bottom were both squares, we would find the volume by just first finding the area of we're finding the area of this base, and we just referred to that as capital B for the area of the base, and then we multiplied that by the height of the prism, and it was a very simple formula: area of the base times the height. In a cylinder, it's the same essential task. We still have a base, and we're still going to have across from that, we're going to have another matching base that is congruent and parallel. So because of that, we can use the same formulas as a cylinder. As a prism. The difference is here that when we find the area of this base, because the base is a the base is a circle, the formula for the area of that circle is going to be pi r squared. So if we think about the formula for a cylinder, we're going to start with our formula for all prisms. The volume is area of the base times the height. In a cylinder, however, the base is a circle, so we're going to be plugging in the formula for the area of a circle and then multiplying it by the height. Now, for a cone comes to a point. So a cone is going to have a single base at the bottom, and then it comes to this point, this vertex at the top. Well, that's very similar to your pyramids from the other week. Pyramids, same thing. We have this base at the bottom and this one point, this vertex at the top. When we were finding the volume of a pyramid, once again, we looked at the area of the base, so whatever that base was. We again multiplied by the height, but keep in mind here that we had to find the actual height that was perpendicular to that base, and we multiplied by that height. But then we realized that it was actually going to take 3 of these pyramids to fill a matching prism. Therefore, we actually divided this by 3. Some people preferred the formula as 1/3 area of base times height. In a cone, since a cone is the same general shape in that it has a base and a vertex at the top, we're going to use the same formula. Once again, the area of the base is a circle. So once again, we're going to be plugging in the formula for the area of a circle, pi r squared, which means that for our cone, we can do area of base, pi r squared, times the height. Remember that the height has to be perpendicular to that base, and again, divided by 3. Now, it is important to make sure that on your cones that you are using the height when finding volume, not the slant height. We talked about slant height in previous lessons when we were finding surface area, and slant height is the height that is down the lateral side or the lateral edge of the cone. So now that we've got these 2 formulas, and again, I'll kind of highlight our formulas, we can use our basic formula for the pyramid and then plug in the area of the base formula. Same thing with the cylinders. We can start with our basic formula for a prism and then plug in the area of the base formula. So if we look at a little application using these formulas, always pay attention to whether you're dealing with a cylinder or a cone so you can be sure you're using the right formula. In this problem, we are given the volume of the cylinder is 450 feet cubed. So right away, I know that the volume is 450 feet cubed. We also know that the diameter is 8 feet. Now keep in mind that if the diameter is 8 feet, then that means the radius is half of that, or 4 feet. Our job is to find the height of the cylinder. Well, because it's a cylinder, our formula for volume is very basic. It's the area of the base times the height. Since it's a cylinder and the base is a circle, we're going to be using the formula pi r squared times height. And now we can plug in the information we know. We have a volume that we can plug in here. We have a radius that we can plug in here, which means the only thing left will be that height. So if we plug in 450 and we plug in 4 for the radius and multiply by the height. Now you could do this all in one step if you recognize, and I'll actually just do this real quick. 4 squared is 16, so we have 16 pi times height. Since we're trying to isolate the height, the only thing we really need to do is divide by 16 pi. And that means that on this side, we also need to divide by 16 pi. By doing that division, 16 divided by 16 becomes 1, pi divided by pi becomes 1, and we're left with height alone. What I want to discuss for just a moment here is how important it is that you put this in your calculator correctly. If you go to put it in your calculator and you type this in, 450 divided by 16 pi, or let's say you do this, 450 divided by 16 times pi. Both of these will give you the wrong answer. And the reason for that is because your calculator is programmed to follow order of operations. If you type either one of these in, what will happen is the calculator will do this division, this division first, 450 divided by 16. Or down here, it'll do this division first. Then the second thing it will do is multiply whatever you got by pi. That's not what we wanted it to do. What we wanted to do was take that 450 and we wanted to divide by the entire quantity of 16 pi. So when you put this in your calculator, you absolutely have to include parentheses around that 16 pi. When done this way, the calculator will actually do the 16 pi first, and then it will do the division afterwards. So be very careful when you're using your calculator. If we do 450 divided by, and then I'm going to open up parentheses, 16 pi, and close my parentheses, I'm going to end up with a height of about 8.9. My units were in feet, so that's going to be feet. Okay? A second example here, I actually wanted to use this one because this gives us an opportunity to look at how we can quickly adapt our basic formulas, and it's also a great review when we get to Tent B of how to go back to some of those other prisms that you had seen before. So Brooke is looking to purchase one of two new styles of tents. One tent is in the shape of a half cylinder. If you envision this tent, Tent A, you can kind of visualize that it's really half of a cylinder. This could go down. There's the other half of the circle back there. The other tent is in the shape of a triangular prism. Since the price of the tents is dependent on the area of the material, Brooke wants to find out which tent will have the greatest volume, in other words, the greatest living space, using the least amount of material. Now, work through the multi-part problem, and we're going to look for both. Eventually, we're going to look for both surface area and volume, but right now we're going to start with just looking at volume. So since tent A is really a half of a cylinder, or a semi-cylinder, we could call it, remember the formula for the volume of a cylinder. It would be the area of base times height, but since the base is a circle, we would do pi r squared times height. Now that would be the volume if we wanted to find the complete cylinder. Since this is only half of a cylinder, all we need to do is divide that by 2 to get the volume of tent A. So if we go back to tent A to get the volume, we're going to do pi r squared times the height divided by 2. Well, we can find the radius in a couple of different places. Since the diameter is 6, then the radius would have to be 3. We could also look at the radius here, and we could see, oh, look, the radius is 3 here as well. So we can plug in 3 for the radius. Now remember that the height is going to be, and I'll make a note of that over here. Height, remember, is the distance between the two bases. So in our example, this is actually our height, the distance from the circle at the front to the circle at the back. So in this case, the height we're plugging in is this 8. We're going to multiply by 8, and we're going to divide by 2. Well, 3 squared is 9. 9 times 8 is 72. And 72 divided by 2 is 36. So it looks like the volume of our tent A is 36 pi. Now, for comparison's purposes, we might want to turn that into a decimal. So 36 times pi is about 113 let's say 0.1 when I round that. And this is in feet cubed since volume is cubed. Okay, now the second figure, figure B, it is described up here as a triangular prism, but I really want to focus on what that means again. That means that the base is actually a triangle. A lot of people are still looking at this assuming that this is the base because this is the part that's at the bottom. But in reality, in a prism, the base, you have to have two bases. They have to be parallel and they have to be congruent. So really, this triangle and this triangle back here, these are the bases, not that rectangle at the bottom. Now, how do we find the volume of a prism? Volume of a prism is area of the base times height, just like we did with the cylinder. But since the base is a triangle, we're going to have to use the formula for the triangle, which is 1/2 base times height. So we're going to find the area of that triangle, and we're going to multiply it by the height of that prism. Now I'm going to do this off to the side. The area of the triangle is 1/2 base times height. The base of the triangle is this 5 feet. The height of the triangle is this 6 feet. So the area of my triangle is 1/2 of 30 or 15. That's what I'm going to plug in here for the area of the base. The height of my prism is, remember, the distance between the bases. So the height of my prism is this 7 feet. And I'm going to be plugging in then that 7 for my height. So the volume of my triangular prism, or tent B, is 15 times 7, which is 105 feet cubed. Now remember that Brooke is looking to decide which of these tents is going to have the most space or the biggest volume. The greatest volume is actually going to be tent A with a volume of 113.1 feet cubed versus tent B with a volume of 105. Now in your homework, you're going to come back and revisit this problem, and you're going to be looking a little bit at the surface area of these so that you can really make a good decision in terms of, now that we know which volume is better, which surface area is bigger, because the higher the surface area, the more you're going to have to pay for the material to make the tent itself. Okay, so we've looked at a couple of examples of cylinders. I would like to now look at a few examples of cones. And again, really pay attention, since we're combining these, to which three-dimensional object you're working with. With a cone, the formula is, for volume, area of the base times the height divided by 3. And since the base of a cone is going to be a circle, we'll do pi r squared times the height divided by 3. So our first example is a fairly basic one. We're given a radius of 6 centimeters, so we can plug that in for the radius. We're given a height of 15 centimeters. We'll plug that in for the height, and we're going to divide by 3. And you can do the multiplication here and the division in a variety of orders. I, for example, am going to say 15 divided by 3 is 5. 6 squared is 36. And 36 times 5 is 180, and then I'm going to include my pi. So my volume is 180 pi centimeters cubed. Okay, fairly basic. You've got the information that you need. But what if you don't have the information you need? So in our second example, the base of the cone has a diameter of 12 inches. So again, remember, if the diameter is 12, then we know the radius is 6 inches, and we have to be using our radius. We then know that the slant height is 10 inches. I want you to find volume and surface area. So we're going to do a quick review of how to find surface area here as well. Okay, Think about the diagram here. So we know it's a cone with a circular base. We know that the radius of our base is 6 inches. So if I draw in that radius of 6 inches, and I gave you the slant height of 10 inches. So there's my slant height, and my slant height is 10 inches. In order to find volume though, volume, remember, includes height or uses height, not slant height. So in order to find the volume, we're going to have to come back and figure out what is the actual height of this cone. And we can find the height by using that Pythagorean theorem, a squared plus b squared equals c squared. Since we know that one of the legs is 6 and the hypotenuse here was 10, if we solve for the missing leg, in our case the height, that's going to be, well, this is 100 minus 36, that's 64. And when we take the square root, looks like our missing height is 8. Once we've got the height, now we can go back and find our volume. Remember that for a cone, it's the area of base times the height divided by 3. Since the base is a circle, it's going to be pi r squared times the height divided by 3. And now we can start plugging in some numbers. Our radius was 6. Our height, not slant height, our height, and I want to emphasize that part of it, was the 8. And then we're going to divide by 3. Again, you can do your simplifying in a couple of different ways. 6 squared is 36. 36 divided by 3 is 12. And 12 times 8 is 96. So my volume is 96 pi. And volume, remember, is in inches cubed. Now, I did say let's also find surface area. So here's a nice little review of surface area. Surface area, remember, will include finding the area of the base. Keep in mind there's only one base in a cone, plus the lateral area. Well, the base is easy. We know that it's a circle, so we're using the formula pi r squared. The lateral area, however, was unique. That one we did a little work to develop it, and we came up with the formula pi times radius times slant height. So remember that for surface area, that's when we use that slant height. Now if we go back and plug in all of our information, our radius was 6. We're going to use that radius again. This time we're going to use the slant height of 10, which means this is 6 squared is 36 pi. 6 times 10 is 60 pi. And 36 pi plus 60 pi is 96 pi inches squared. Now you will notice that this is one of these unique situations where our volume and our surface area do in fact match. It is possible for that to happen. It doesn't always happen, but it could. So a quick review of a couple of things before I send you off to try some of your homework. I wanted to review, your basic formulas. If we are dealing with a prism or a cylinder, our volume is just area of base times height. If we are dealing with a pyramid or a cone, our volume is area of base times height divided by 3. When we are dealing with surface area of a prism, there will be 2 bases plus the lateral area. Surface area of a pyramid or cone will have 1 base plus the lateral area. I do think it's important to remember a few things about some formulas about circles in general. We know that the area of a circle is pi r squared, but you also want to remember that the circumference of a circle is 2 pi r. And keep in mind that using these formulas, you can actually use these formulas if you are given an area or a circumference. You can use these formulas to find a radius if needed. Okay, the other thing to remember then is the difference between the slant height and the height. Remember that the slant height is kind of down the side of the pyramid versus the height, which is perpendicular to that base. Now, the one thing that we do know is that the slant height and the height will form that right triangle, and therefore we can use your a squared plus b squared plus c squared when needed if we're missing one of those 2 pieces of information. So As you try some of your homework tonight, remember you are going to see a mixture of cylinders and cones, so pay attention to which one and which formula to use. You'll also see the occasional problem that asks about surface area so that